Good day, everyone. My name is Manuel Luiso Gomez, but you can just call me Master Manuel. What is a computer?
A computer is a machine that can be instructed to carry out sequences of arithmetic or logical operations automatically via computer programming. A calculator can perform arithmetic, thus, it is a computer. This thing, what is known as a mechanical computer, is also a computer. It doesn't have to be electronic.
A device operating under the control of instructions stored in its own memory that can accept data, process the data, produce information. Any digital computer carries out 5 functions in gross terms. Number 1, takes data as input. Number 2, stores the data or information in its memory and use them when required. Number 3, processes the data. Number 4, generates output. And number 5, controls all the above 4 steps. Next, we have the 2 main components of the computer, hardware and a software. For the software, we have 2 types of software. We have the system software and we have the application software. For the system software, the one responsible for the overall function of the computer. For the application software, these are the programs that you use for your own purposes. Next, we have the hardware. Okay, all the parts of the computer that you can see, you can touch using your hands.
Input and output devices are hardware. Input devices allow the you and the world to interact with the computer, such as mouses and keyboards, and output devices allow the computer to interact with you and the world. Processors and memory devices are also hardware. The most important part of a computer is the CPU. The CPU consists of 3 main parts: the arithmetic logic unit, the control unit, and the registers. The arithmetic logic unit is responsible for all the arithmetics and calculations. The control unit receives data and tells the arithmetic unit and the registers what to do. The registers store instructions when needed. Each CPU has different register sizes. These 3 work together and allow the computer to operate.
Now let's move on to storage devices. We have 2 types of storage devices. We have the primary memory and we have the secondary memory. Now let's talk about the primary memory. First, let's talk about RAM, or what we call the random access memory.
The RAM stores temporary memory. RAM only works when supplied with electricity. It can be written and erased quickly at any time, so it is used to store data of running programs. Once RAM loses power, all the data stored is lost.
Next, we have the ROM, or read-only memory. ROM is a permanent form of storage, stays active regardless of whether the power supply to it is turned on or off. It doesn't allow data stored on them to be modified. Okay, so it will never be modified.
Important data such as boot settings are stored on ROM.
Next, let's go to the secondary memory.
Secondary memory can have data written to it, which is retained after power is turned off. The data can also be overwritten or erased.
Now let's move on to types of computer. Computers can be broadly classified by their speed and computing power. Number 1, we have a personal computer. It is a single-user computer system having moderately powerful microprocessor. Next, we have a workstation. It is also a single-user computer system, similar to personal computer, however, has a more powerful microprocessor. Mini computer. It is a multi-user computer system capable of supporting hundreds of users simultaneously. Next, we have a mainframe. It is a multi-user computer system capable of supporting hundreds of users simultaneously. Software technology is different from mini computer. Next, we have the supercomputer. It is an extremely fast computer. Okay, now let's move on to the history of computers. Earliest computer. Originally, calculations were computed by humans whose job title was computers.
Then mechanical calculators were made to make things easier.
Okay, the ENIAC computer. It was the first electronic general-purpose computer. The founder were John Presper Eckert and John W. Monk. Completed or created in 1946. Okay, computer generations. There are 5 generations of computer. The first generation was in 1946 to 1958. The first computers used vacuum tube, magnetic drums for memory and were often enormous, and it was very expensive. Second generation was 1959 to 1964, uses transistor, allowing the computers to become smaller, faster, cheaper, more energy efficient, and more reliable. Third generation was 1965 until 1970. Transistors were miniaturized or placed on silicon chips called the semiconductors, which drastically increased the speed and efficiency of the computers. Okay, much smaller, cheaper, okay, compared to the second generation. Fourth generation was 1971 until today. This is what we use. The microprocessor brought the fourth generation of computers as thousands of integrated circuits were built onto a single silicon chip. And the fifth generation onward is today, up to the future.
In order to get fourth generation computers to do what you want, you needed to use programming languages. Fifth generation computers are still in development. The goal is to make AI that could understand and respond to natural language.
Okay, now let's move on to memory unit. Let's start from the smallest memory unit up to the biggest memory unit. First we have the bit. This one is the smallest unit of computing. Next we have the nibble. Nibble is composed of 4 bits. Next we have the byte, equivalent to 8 bits, or a single letter on the keyboard. Next we have the kilobyte, composed of 1024 bytes, or a single picture. Next we have a megabyte, equivalent to 1024 kilobytes, or an MP3 song. Next we have a gigabyte, equivalent to 1024 megabytes, or a single movie. Next we have a terabyte, is equivalent to 1024 gigabytes.
DPI is the resolution of an image. DPI can be calculated by dividing the wideness of an image in inches to the number of dots or pixel wide, or dividing the tallness of an image in inches to the number of dots or pixel tall. Both gives the same number. The more DPI, the better the image looks.
Next we have the bit depth. Okay, this one is the color that the picture is using. 1-bit picture only uses 8-bit picture. It uses 256 colors. As you can see, the size becomes bigger. Okay, next we have a 24-bit picture. It uses 16,777,216 colors. Okay, next let's move on to calculating image file size.
This image is 33 pixels tall and 16 pixels wide and has a bit depth of 8. To calculate the file size, find the amount of total pixels and multiply with bit depth, which gives us the answer in bits. To convert bits into byte, divide by 8 and you will get your answer.